This is lesson 18, and as you can tell, the title of it is More Transistor Circuits. So the last lesson we looked at what a transistor is. We did quite a bit of theory about transistors, and you actually did a little bit with a transistor circuit, but in this lesson we're going to look at several more. I've talked just a little bit about several different types. We are actually only going to do two of these. We're going to do a really simple one and then one that's a little bit more complicated, but still not terribly complicated. The first one we're going to look at is called the emitter-follower amplifier, and basically all of these are amplifiers of some sort. The emitter-follower is called that because the emitter voltage follows the voltage changes at the base, and so it follows. Now on the next page, on page 150, we have a circuit, and I did not have a diagram of this already drawn anywhere, so I am going to do this on the board and explain it just a little bit as we go along. So it is in the book, mostly what's in the book. So we're going to start by drawing our transistor. We sort of always start there. We have our transistor, and in this one it has a number 2N3904. And I think when I sent these out, I sent two different transistors. One is this one, and one is a 2222, which you will use in the next circuit. Now, we're not going to go into the details of why these are called these different numbers. We're just going to use them. And I guess part of my philosophy about this actually and the next two lessons that deal with a number of these circuits, there are times in physics when I feel you should understand how everything works. And that was in probably the first unit and the second unit. But now we're going to look more at how do we assemble things. You're going to get more practice at constructing these circuits. My analogy is maybe like a bicycle and a car. So most people have a pretty good idea of how a bicycle is constructed, and probably if necessary and you had parts lying around, you could put things together and make a bicycle. But as far as a car is concerned, most of us probably could not do that. We do know a few things about operating a vehicle, but we don't know all of the details about everything and how everything is put together. So that's kind of where we are now in these circuits. We know a little bit, but we don't have to understand everything that's going on in all of the devices. So our transistor, we have it, and we generally draw it oriented this way. This is the emitter, and this is the collector, and the base is always drawn out the other direction. Okay? So when we look at the actual transistor, this is usually the flat side of the transistor, and we have the collector and emitter legs, as they're called, out here, and then the base is out the back. Now, we're going to connect a resistor here, and this is the base resistor. It is 330 ohms, and so from the color code, this is a red, red, red. Okay? Now, I'm going to write VN here mostly because that's what he has in the book. And then we're going to see later what we actually do with this. Okay? So we're going to connect our collector to a positive voltage. And on our circuit board, this is going to be to the positive 15 volts. And that is the yellow terminal. Okay? So then down here we have another resistor. This is our emitter resistor, which is 3.3 kiloohms. So again, it's still a red, but it is, oh, I have these, this should be an orange red. Okay, 3 is orange, so 3, and then times 10, maybe this is right, brown. I think in the write-up I have it, I just have it labeled wrong on my picture here. So we have 3, so this should be orange, and then remember that the kilo moves the decimal over 3 places, but in our color code we have 2 digits and then we have the power of 10. So it's 33 times 10 to the 2, so that should be orange, red. Okay. Then this goes on down to our minus 15 volts. Oh, I should put that in a circle up here. So this is our plus 15 volts, and this goes to minus 15 volts. Okay. Now, in doing this, the circuit board, the knob says that it will go to 15. It actually will go a little bit farther than that. So now I think I will go to the circuit. We will look at that. Oh, before we do that, something else we need to do. Okay, the second part of this is after we do some experiments or some measurements with this, we're going to calculate the gain, and it tells you what equations to use for the various calculations. One thing you want to watch is that I do tell you which voltage scale to use. There are several of these that you need to use millivolts. So make sure that if it says MV for the voltage that you use the millivolts. Okay, the second part of still using this same circuit is to determine the DC voltage shift VBE. So it's the voltage between the base and the emitter. And in that circuit, you're going to use the oscilloscope. Actually, I'm not going to connect it because you've been doing a number of things with the oscilloscope, so you should be somewhat familiar with that. The one thing that is important though, in part A, it says to remove the ground wire. So in the first instructions, it says to ground this, which I will show you there. And then in the second part, you need to remove that ground wire. So let's go to our circuit and I'll show you a few things. And this is the one that we need here. So what I've done, I've actually have 2 circuits set up here. This other one is the second one. But notice I have the transistor here, the flat side to the right. I have a resistor out here and one up here. This one is connected to the base. So this is the orange-brown, which is what I changed that one to. And then this one is the one connected to the emitter. So it's orange-red. And then we needed to go from this end to the negative 15 volts. So if you follow this black wire, it's hard to see because everything's black, but this black wire goes under here and to the negative 15 volt terminal here. And then our collector, which is the top side, where's my plus 15? Oh, I may have this in the wrong hole. Okay, collector goes here. So we have the collector going to the positive 15. And then from our base, we needed to go to ground, because one of the instructions was to ground the base resistor. So after we have this, and then you can turn it on, something always you want to kind of notice is if you see or smell any smoke. You also want to kind of check for things getting hot, but the best thing is not to actually touch them, because I did that once on a amp that was something that was not working right, and it was very hot. So you can put your hand over the circuit kind of like this, and if you feel a lot of heat, then you should probably turn things off and kind of try to figure out what was not right there. So with this circuit, you're going to be measuring the voltage across each resistor and then doing some calculations. So you'll use the orange meter. You could probably use the other one too, but I've been using the orange meter and having it set. And these voltages, at least for right now, are all DC voltages. So you want it set on the DC voltage, and I think I actually put that there. So that will take care of the circuit, the emitter follower circuit. Now, I think we'll go back to the board now that Adrian has that under control. I should have just done both of them to begin with. The other circuit is called a self-biasing common emitter amplifier. On page 152, there is a general circuit for that, but if we go on over to page 155, there's a more detailed circuit that you're actually going to construct. However, before you get to that circuit and the experiment, there are a couple of pages where you have to do some calculations. So if you're going to design one of these, you need to be able to figure out what values of resistors that you want in the various places. Now when we did this one, I just told you what to put. So under design, there are a number of steps, and I have the equations for you to use to put in the values so you can actually end up calculating a resistance for the different resistors. Now, it turns out that when you get those two, the R1 and R2 calculated, they aren't going to be ones that are commonly used, and that's kind of the whole idea with all of this. You go through designing the circuit, and once you have the resistors calculated, then you have to find ones that actually exist. So, since I know what you should have ended up with, which I'm not going to tell you what resistors you'll end up calculating, but ones that we have are a 10 kilo ohm, not 10, a 15 kilo ohm and a 2.2 kilo ohm resistor. So those are the ones that we're actually going to use. Now, I'm going to draw just a little bit of this circuit because there's a couple of things I want to point out, but I'm not really a fan of drawing complicated circuits. So the two things that I need to show you are that here Okay, here's the transistor. It comes out and here, and we have a resistor here. And this is the emitter resistor. Then it shows a little line down here, and I think it shows maybe a horizontal line or maybe not. This has to do with the diagram that the figures that my husband drew on his computer a few years ago when he was teaching the class, and then getting those diagrams from his computer and a different computer and onto my Mac that doesn't really seem to like some of these things. Not all of the lines end up showing up, so that's what I wanted to emphasize. This is a ground at this point, so you might want to actually draw that. Now, another thing that shows up here, we have the base here and we have another resistor here. This is R2. Then this goes on up. There's some more things up there, and that's pretty much basically what the diagram shows. But the other thing that we want to look at is that there's a capacitor out here, and this is called C1. And you're going to use a 220 microfarad capacitor. It's an electrolytic. It's one of those with a little can. It's bigger than kind of those flat ceramic ones. And for the electrolytic, you really should try to keep track of the plus and minus and have it in the circuit oriented properly. It usually doesn't make a lot of difference if the voltage isn't very much, but since in these it's hard to tell without doing a lot of calculations what voltage we're going to have for these. So we want to put a minus on the right side, because you can see this kind of goes down here to the ground. And on the other side is the plus, and this is going over here to the function generator and to the positive input. So when you put the capacitor in here, if you look on the side of it, there are some black lines that indicate the negative, and I think that the negative lead, the little wire from that side, is also shorter than the other side. So be sure you get the capacitor in here oriented like that. Okay. Oh, while I'm up here at the board, there's one more thing that I want to point out, and this is in step number 9. In step 9, you're going to be looking at the input and the output of the function generator. You're going to be looking at it on the oscilloscope. Two things. You're going to look at both channels. The input is on channel 1 and the output is on channel 2. And if you look back at the figure, it shows you on the diagram where you're supposed to connect the channel 1 probe and the channel 2 probe. And I also believe that I have very detailed instructions. The main thing with the instructions is that you want to read all of each instruction. There's a tendency to kind of read every fourth or fifth word, and that's not going to work very well. And for the instructions where there's several sentences in for one number, you want to read each sentence carefully and make sure that you do exactly what it says. So I know that sometimes I don't follow instructions very well, but on these things you really need to read them carefully and follow them and not skip words. Okay, in number 9, two things that it says. You're going to be looking at both channels, and if you want both channels at the same time, then you have to set the vertical selector mode to dual, and it will show you both channels. The other thing that it says is be sure that the channel 2 INV button is out. And the reason I say that is because from the previous lab or previous lesson, you had to subtract the two channels, and for subtraction you had to add a negative, and the INV button made the inverse, so that was the negative. And unless you pushed it when you got done with that to have the button go out, then it's still in, so it needs to be out. Now, what you're going to do is, it says to sketch the graphs, and I would recommend that you draw your input. Well, after you figure out what these look like, I would say the input should be not very tall. 1, 2, maybe 3 cycles. I don't think I said how many cycles. Okay? And you should label this. So this should be input. Okay? And then on top of this, you should put the output. The output is channel 2. I might go ahead and put over here, this is channel 1, and I'm not going to draw channel 2 output because I want you to see what you get. But the input, you'll notice that I don't have it very tall, and I guess it's okay to tell you that your output will be bigger because that's kind of the whole idea for most of these, is that they're amplifiers. Now, there are some voltages to measure, and you won't be measuring them with a meter. You'll be measuring them on the oscilloscope. For some of these, I have a place for you to count the number of centimeters and use the volts per division so that you can multiply however many centimeters tall times the scale that you have it on to end up with a particular voltage. And then there are some other equations that you need to use to solve for the gain, the voltage gain. So the main thing is follow the instructions carefully, and then you should be able to figure out what you end up with for your graph and then for a voltage gain.
Good.
Actually, I need to move these chairs. Okay, I still have, now that I moved the circuit board.
You're fine.
I have the circuit set up from when I was doing it earlier. This is the one that we just did. This is the one that we're going to do now. So generally you start by putting the transistor, and notice that it tells you that the transistor is the 2222. So you want to be sure that you have that one. And make sure that you have the proper resistors and in the right places. Here's the capacitor. Notice that the short end, I'll just take it out here. The short end is the one that goes over toward the base of the transistor, and then you're connecting the function generator. Make sure that you notice whether it tells you sine wave. I think you probably use a sine wave, and it also tells you what frequency to use. So we'll have this connected up here, and then we have the ground from here connected down here. This is kind of the standard way that you use the function generator to apply an input. So that's basically the circuit that you will have. And then make sure, as I said, make sure you follow the instructions on how to assemble it and where to put probe 1 and probe 2 and what measurements to make and what calculations to make.